So we have y prime prime. Our y prime prime is said to be, so we are going to substitute there. Instead of y prime prime, we have it to be this, which is x all upon 1 minus x squared all raised to power 3 over 2. Then we have minus, which is this. We already have x here, which is this. Then y prime. Do we know y prime? Yes, equation 2 is y prime, which is the whole of this. So we are going to replace y prime to be 1 all upon square root of 1 minus x squared. So that becomes x times, instead of y prime, we now have 1 all upon square root of 1 minus x squared. Okay, let's simplify. As a matter of fact, you find out that this is the same thing as, of course, look at what we have here. We have 1 minus x squared times x into 1 minus x squared to power 3x. Of course, we can have this to be that 1 minus x squared all upon 1 minus x squared all raised to power 3 over 2 times x, which is equals, which of course followed by minus, we have x, then times 1 all upon, this is the same thing as 1 minus x squared all raised to power 1 over 2 from the law of indices. When we have root a, it's something as a to the power 1 over 2. Take note. Now, look at what we have here. Of course, this is the same thing as 1 minus x squared divided by 1 minus x squared raised to power 3 over 2, because this is dividing that, which means the numerator, which is 1 minus x squared divided by 1 minus x all raised to power 3 over 2, all this times x, then followed by minus, which is this, then we have x times 1 all upon 1 minus x squared all raised to power 1 over 2. Now, from the law of indices, we are told that a to the power m divided by a to the power n, a to the power m divided by a to the power n, once they have the same base and what is connecting them is division sign, you subtract their powers. So this will give us a to power, what's the power here? M. Because of division, you subtract. What's the power here? N. Applying this here, we're going to have this to be, of course they have the same base. The base here is 1 minus x squared and its power is indivisible 1. And here, divided by, the base here is also 1 minus x squared and its power is 3 over 2. You find out that they have the same base. As a matter of fact, we are going to, and what is connecting them is division sign, we are going to subtract their powers. So this is going to give us 1 minus x squared. What's the power here? 1 minus the power here, 3 over 2. Times x, that's this particular x, then followed by minus, which is this, x times 1 all upon 1 minus x squared all raised to power 1 over 2. Let's clean the board. But remember, our target is to show that the solution of this will be equals to 0. So if the entire solution of this becomes 0, then the problem has been proved. Because we are asked to show that this is equals to 0. Okay, let's simplify further. So we have 1 that becomes the base, which is this 1 minus x squared raised to power 1 minus 3 over 2. Let's solve 1 minus 3 over 2. 1 is the same thing as 1 over 1, which is still 1, minus 3 over 2. LCM of 1 and 2 will give us 2. 1 into 2 will give us 2. 2 times 1 is 2. This minus is this. 2 into 2 is 1. 1 times 3 is 3. Therefore, that becomes 2 minus 3 will give us minus 1 all upon 2.